Okay, so I'm recording now. Recording. Okay, I'm recording. All right. So we have discussed question A. Okay, question A in the class. Okay, how to find the current I1, I2, and I3. Okay, if you forget about how to find this current, you can also refer to my previous video. Yeah, I have made many videos regarding how to find current in this circuit using the Kirchhoff first law and second law. Yeah, so you can refer to my previous video how to find the current. Now I want to continue with question B. Okay, so question B. But first of all, I need to list out what's the value of I1, I2, and I3 because I will need it. I1. Okay, what is the I1? Let's see. Okay, so this is question 9. So I need the answer for I1, I2, I3. So bottom line answer. Question 9. Yeah, question 9. Okay. Question 9. Okay, how come? Oh yeah. This one lah. Yeah. So okay, I just snapshot this one. Question 9. Okay. This is the value lah. Yeah, this is the value of all the current. Now, okay, what is the number of electron passing through the 9 ohm resistor in 2 seconds? Okay, hold on a second. Close the door. All right. Question B. Number of electron passing through the 9 ohm resistor in 2 seconds. So that means 9 ohm resistor, this one. Okay, what is the current passing through? What is the how many electron passing through this 9 ohm resistor? So first of all, you need to find the total charge. Total charge passing through the 9 ohm resistor. Okay, so the formula is Q. Yeah. If we want to find the total charge passing through the 9 ohm resistor, we need to know the current also. So current multiply time, yeah, Q equal to IT, you get the total charge passing through the 9 ohm. After that, you got the total charge, you use the formula Q equal to NE, then you can find the number of electrons. Okay, the total charge divided by charge of 1 electron. Okay, now what is the current passing through 9 ohm? We must know what current. Is it I1, I2, or I3? We actually labeled before. Okay, negative, positive, negative, positive, negative, positive. So actually, current I1, this I1. Okay, I1. Yeah, and here it is I2. Yeah, I2. So current I2 actually, yeah, passing through the 9 ohm, and then I3 is over here. I3. Yeah. So for 9 ohm resistor is I2 lah. Okay, so it is, we must use current 2. Yeah, current 2 passing through the 9 ohm. So the rest is just substitute the value. So I2 is 0.986 multiplied by the total time taken is 2 seconds. So what's the answer for this one? What's the answer? Okay, 0.986 multiply 2. So I got, 0.986 multiply 2. I got, hey, something wrong. Something. 0.986 multiply 2. Yeah. Oh, okay. So I got 1.972. Right? Yeah, Coulomb. After that, you know, you can find the total charge 1.972, number of electron 1.6 exponent negative 19. So just divide, you know, divide by 1.6 exponent negative 19. Okay, so the answer will be 1.23 exponent 19 electrons. Okay, understand? So how about question C? Question C, power dissipated by 5 ohm resistor. Power dissipated by 5 ohm resistor. So now 5 ohm resistor is this one. Okay, so 5 ohm resistor, power loss, power dissipated is power loss. Power loss. Normally, to find power loss in resistor, we use the formula I square R. Okay, I square R. And then the current passing through is I3. So make sure you use the correct current, I3. So I3 is 0.425 square, and then resistor is 5 ohm. Okay, so answer 0.425 square and multiply 5. Okay, I square R. So the answer is 0.903 watts. That's right. Okay, so that's the power loss, power used in 5 ohm resistor. Now, D, energy supplied by 7 volt battery in 2 minutes. Energy supply. So this time is energy supply by which battery? By this 7 volt battery. So to find energy supply, if energy is actually power multiplied time. Just now you find power. So energy is the power multiplied time. Okay, power multiplied time, because power is energy over time. So for energy supply, normally for energy supply, we use the or power supply. Just now is power loss, power dissipated. We use I square R. If power supply, normally you use the formula IV. IV, understand? Or you can write as VI also. IV or VI. So energy supply is VIT. Yeah, just extra a T, time, for energy supply. Okay, so you use 7 volt, and then current passing through is I1. Okay, that one is I1. So it is 7 volt multiply I1. So I1 is 0.562. 0.562, and then time taken is 2 minutes. 2 minutes is convert to second, 60 seconds. So answer 7 multiply 0.562 multiply 2 multiply 60. So it's 472.08 joule. That's it. Okay. Now question E. Question E. What is the change in resistance of the 2 ohm resistor when there is a 30 degrees Celsius rise in temperature? So this is actually delta T. You know that? And this is the initial resistance R0, and temperature coefficient of resistivity, this one is alpha. Okay. So change in resistance. So the change in resistance means you need to find delta. Sorry, you need to find delta R. Okay. So delta R. So actually the formula is, what's the formula? Delta R equal to alpha R naught delta T. Okay, how do you get this formula? Yeah, actually because last time when we learned about this formula, if you still remember, the formula is R equal to R naught 1 plus alpha T minus T naught. So from this formula, we can derive to get this formula. Alright, so this is actually almost like thermal expansion formula, yeah, if you remember, thermal expansion, yeah, in semester 1. So okay, let's yeah, if you look, yeah, the original formula is R equal to R naught 1 plus, sorry, 1 plus alpha T minus T naught. This is the original formula. Okay, so next you this one T minus T naught actually is delta T. So alpha, so R naught plus, you know, R naught, R equal to, you know, R naught multiply, yeah, you know, expand this, R naught multiply into it. So I got this, and then R naught go to the other side, R minus R naught, R minus R naught equal to alpha R naught delta T. So R minus R naught is like T minus T naught delta T, delta R. So here you get delta R equal to alpha R naught delta T. Do you see that, class? That's the formula. Change in resistance is this formula. Okay, so use this formula. So alpha is 6.8 exponent -3. Okay, R naught is 2 ohm. Change in temperature is the 30 degrees Celsius rise in temperature. So this is change in temperature because it's a rise in temperature. Yeah, delta T, remember, delta T, you can either degree Celsius or Kelvin, because it's about change, yeah, or rise in temperature. So it's about change in temperature. So this one not necessarily must always Kelvin. Yeah, it must not necessarily must always Kelvin. You can also put in degree Celsius. Yeah, either you need, no need to change. Okay. Calculate 6.8 exponent -3 multiply 2 multiply 30 degrees Celsius. Yeah, so the change in resistance is 0.408 ohm. That's the change in resistance. Okay, class. Understand, class? Yeah. Okay, so very easy only, yeah. So okay, so go next. Okay, class, I need to grab some water, yeah. So I pause recording for a while. Okay, I'm back. So I'm continue recording. All right, are you back as well? Okay, so let's continue. Yeah. Let's go back to the question. Okay, we have discussed question 8, question 9. Question 10, hold on a second. I think I want to go straight to question 12 first. Yeah, I want to go straight to question 12 and question 13. Okay, I want to discuss these two questions first because I want to cover about potentiometer. Yeah, because I worry about your exam. Yeah. Next Tuesday is your UPS. In fact, I just want to tell you that you can look at my, you know, our Telegram bot. Yeah, over here. Yeah, tutorial. At the quiz there. So you see the chapter 1, chapter 2, chapter 3 quiz. I just posted the PDF version. Yeah, the PDF version. Please answer this quiz by this week. Yeah, as soon as possible before your UPS. Okay, chapter 1, chapter 2, and chapter 3. So there are PDF version with answer key behind. See, these are the questions, and behind there is a answer key for you to check your answer. Understand, class? So please try all these questions before your exam. Yeah, at the Telegram bot. All right, class. Can you do the question? Okay. Make sure you do. Make sure you do the question. At the Telegram bot by this week. Yeah. Don't do after UPS. Do before UPS. All right. Okay. So go back to our look at question 12. Okay, I already taught you about potentiometer. So let's try some question. Okay, let's try some question. Let's copy this and okay. So about this one. Okay, you already learned about what is potential divider, kan? Potential divider. Meaning that, for example, like if resistor 2 is a bigger resistor, then voltage 2 also bigger. Resistor 1 smaller, voltage 1 also smaller. Yeah, same thing goes to if resistant wire. You have a resistant wire. If L2 is longer, then V2 also higher voltage. L1 shorter, then V1 also smaller voltage. This is a two resistor in series. Yeah, two resistor in series or uniform homogeneous wire. Must be in series, not parallel. Yeah, must be in series. So these are the formula lah. Yeah, these are the formula how to calculate the voltage. This one actually you just use Ohm's law to derive. Yeah, I show you before. So now let's try one questions. So this question. Calculate the output voltage. Recording already. Okay, calculate the output voltage. That means voltage across the 3000 ohm. How? Use the formula. How? Maybe we can put it this way. Along here, okay, here is put it as V1. Here, this is V2. Okay, class? And this is R1, this is R2. Okay? Good. So now, what is V1? So calculate. This one is V total. So V1, yeah, output voltage is equal to R1 over the R total lah. R total. Yeah, multiply V total. Yeah, or we can write it as like, you know, R1 over R1 plus R2 because they are in series. Kalau resistor in series, kita tambah-tambah. Betul tak? Kita tambah-tambah. So in fact, this is R total lah. The whole thing is R total. But we just want the voltage for R1 only. So you just put R1 and find the voltage for R1. Okay, continue. So V1 is equal to, this is 3000 ohm R1, and then 3000 plus what? Plus R2 is 6000, and then multiply by total voltage 12 volt. So what's the answer? Let's find out. P over 9, over 9 multiply 12. 4 volt. Yeah, 4 volt. So I got it. V1 is, V1 should be 4 volt. And what do you think will be V2? V2 of course will be 8 volt. 4 plus 8 you get 12. Yeah. V total actually is V total actually is V1 plus V2. Yeah, V1 plus V2, because series, kalau series voltage dia tambah-tambah. Yeah, 8 plus 4 you get 12. So the output voltage, which is V1, is only 4 volt lah. Yeah, you see? Smaller resistance, smaller voltage. Bigger resistance, like 6000, you get higher voltage. This is called potential divider. Potential divider. It divide the voltage according to the resistance. Divide the voltage according to the. Okay, so let's do question B. Now, if you have a voltmeter of resistance 3000 ohm, connected across the output, so determine the reading of voltmeter. So I have a voltmeter of resistance 3000 ohm connected across the output here. What is the reading of voltmeter? That means, what does it mean? It means that, I draw the circuit again. It means that this is the battery, 12 volt battery. Okay, here, oops, what is this? Okay, in fact, he say here is a 3000 ohm, here is 6000 ohm. This is R1, this is R2. This time he put another voltmeter across the output, across the 3000 ohm voltage output here. He put that. So that means here got another, I can say another resistor. Also 3000 ohm. So I can put this as R3. But this one is actually a voltmeter lah. It's actually a voltmeter. Yeah, connect. So I want to find the voltage across here. What's the voltage across this part? So how to find the voltage across that? So remember, you can change, combine these two first. Oh, okay. So that means you can combine them. So this is R13 lah. This is R2 lah. Okay. So I want to find the voltage across this, because you already say he put the voltmeter across it. Yeah. Question say find the reading of voltmeter We connected across the output. That means across a 3000 ohm. We connect the voltmeter. So find the voltmeter reading across R13. So how? What is the voltage across? What is the voltage across this one? So class, go back to use the potential divider formula. Potential divider formula. So V, this is a V13. So V13 equal to this time R13 also in series with R2. So it is a R2 over, I can say V total lah. It's not V total. So what I'm doing? Actually, I'm getting dizzy already. I'm getting dizzy. Oh no, not R2. What I'm writing, you see, I'm blur already. This is R13. Okay, class. I'm wrong, but you'll never correct me. Everybody is so silent. That's why I feel like I'm talking alone here. I feel like I'm talking alone. Yeah. Don't know you are listening or not. R13 out of the total resistance. Yeah, so it is just put as R total lah. Multiply V total. Okay, class?
Yes, sir.
Okay class? Ya. Bagi saya semangat sikit lah. Kan? Tak salah mah. Macam you buat baik juga bang. Buat pahala juga. Kalau you bagi saya semangat. Ya. Pahala juga. Siapa tak nak pahala? Okay, ini R13. Kena cari R13 dulu lah. Kena combine ini dulu. Ya, kelas? Ini kena combine dulu. Kasih combine ini. Combine kepada 1. Combine kepada 1 dulu. R13 dulu. So, ini adalah parallel kan? So, parallel punya macam mana buat, kelas? Cepat. Parallel. Voltmeter. So R13 equal to 1 over kan? 1 over R kalau parallel. 1 over R1 plus 1 over R3. Ya. So ini 3000 ohm plus semalam kan saya pengsan atas sofa ya. Pengsan sampai jam 2 pagi, terbangun jam 2 sudah. Baru nak wash the dishes. Banyak dishes on the kitchen. Jam 2 pagi saya bangun untuk bersihkan pinggan dan bersihkan botol susu anak. Itulah, tak cukup tidur jadi. Terlalu penat. Berehat sekejap saja atas sofa terus tidur. Tidur dan bangun jam 2 pagi sudah. Kena bersihkan ya. Dan jam 5 bangun lagi. Nak sediakan anak untuk ke sekolah. Okey, itulah. So, this is 2 over 3000. Remember, this is just 1 over R13 ya. So if R13, then kita kasih apa? Terbalikkan. So dia jadi 3000 over 2 lah. Jangan lupa terbalikkan. So 1500 ohm kan, kelas? So now this R2 is 6000 ohm, but R13 now is 1500 ohm. Okay? So right now ini kena tulis apa? Ini kena tulis 1500 ohm. Out of the total 1500 plus 6000. So cari R total. V total is 12 volt. So berapa kelas? Cuba bagi tahu saya. Tell me. Tell ya orang yang ini ya, yang Melayu kesian saya. 1500. Hah? Berapa ya?
2.4.
Okay. 2.4 Alright, 2.4 volt. Itulah. Ya, potential divider. Senang je kan? Ataupun you nak guna cara lagi satu, yang simple punya pun boleh. You guna cara tradisional tu, V equal to IR, cari current dulu. Ya, cari current dulu. V total, I total, R total, cari current dulu. Ini 12, cari I total. R total ialah berapa? R total ialah 1500 tambah 6, 1500 tambah 6000. So 7500. Cari current kan, cari current total. So berapa kan? Lepas tu V equal to IR lagi. V equal to IR lagi. Kali ini untuk apa? Untuk apa? V13 je. I13 multiply R13. Okay lah, tak apa buat ya. Kita 12 bahagi 7500. So berapa? 0.0016 ampere. So we know that the current is the same, right? The current is the same. I13 is also the I total. It's the same. Same current. Multiplied by R13 is 1500. Cuba multiply 1500. So what do you get? See that? 2.4 volt. It's the same thing. Still get back the same voltage 13. Okay, class. This using potential divider formula. Potential divider formula. This one just use Ohm's law. V equal to IR je. Boleh kan, kelas? Boleh faham? Okay, good. So next, go to next question. Yeah, go to next question before I pengsan. No, almost ready. Almost. You know. Okay, so let's do this. Nothing else I want to do. It's just, fall onto the date. It's the thing I want to do. Okay, let's do this question 13. Yeah, question 13. Figure 10 shows a potentiometer circuit consists of uniform wire XY of length 100 cm and is resistance 5 ohm. So what he's saying here is this is a potentiometer. It has a uniform wire XY. You see here? Here actually is a resistant wire. The whole wire here, the whole length here is actually resistor. XY is actually a resistor, a very very long resistor, 100 cm long resistor. This XY is a resistor 5 ohm. So right beside length XY, the whole length is 100 cm. The whole length is 100 cm from X to Y. Resistance XY is just apa? Yalah. Resistance XY is the whole length is 5 ohm. Okay, class? Yeah, 5 ohm. Now, he's saying that EMF of cell A and B is 4 and 3 volt. So here you can see two battery here. Battery A is 4 volt. Okay, you can this is actually EA. This is 4 volt. This is EB. EB is a smaller battery, 3 volt. Okay, class, it's like this. Always the top one has to be a big battery. Below is a small battery. It must be like this. Then only you can get zero current. Can get balance length. Then only can get balance length. L. Then only the LXP will become balance. Yeah, when current equal to 0 ampere. So LSP become a balance length. Yeah, if you terbalikkan, if you put EA at the bottom, EB at the top, that means bottom is a big battery, top is a small battery, then you won't get zero current. The needle always deflect to one side. You can write a notes there. Write a notes there, class. When I ask you to do something, you do. You do right away. If EB, if EB is bigger than EA, ya, kalau EB lebih besar daripada EA, then cannot obtain balance length. You tak boleh cari point dalam needle ini, dalam wire ini, di mana Gaumeternya show zero reading. Ya, you cannot obtain a balance length. Kalau di bawah bateri besar, atas bateri kecil, you cannot obtain balance length. What will happen is the galvanometer needle will always deflect to one side. Will always deflect to one side. Okay. The galvanometer reading will always deflect to one side. Yeah. Cannot get zero current. Cannot get current equal to 0 ampere. Dia mesti bawah kecil, atas besar. Kalau bawah besar, atas kecil, the galvanometer needle will always deflect to one side. And cannot get zero current. Cannot get needle near point to the zero. Kenapa, kelas? Kenapa atas mesti besar, bawah mesti kecil? Why top must be big, below must be small? Remember? The reason is very simple. Because big battery is for long wire. Small battery is for shorter wire. That's it. Shorter wire. Okay? Okay, class? Question A. What is the length of XP when galvanometer reading is 0? Galvanometer reading is 0 means apa? Means I equal to 0 ampere. Get balance length. That means this length will be balance length. A balance length. So what is the balance length XP when current equal to 0? So what is it? Use ratio, class. Use ratio. Remember the concept I told you? Resistance always proportional to the length, proportional to the voltage. The longer the wire, the bigger the voltage it takes, the bigger the resistance. The longer the wire, I see XY is longer than XP. So XY is for 4 volt, XP shorter wire for smaller battery, 3 volt. Tak boleh terbalik. Kalau terbalik, dia akan jadi the following question lah. Kalau macam ini, Question 14 kan, bateri ni terbalik. So bawah besar pula. Kalau bawah ni for long wire, and then there's PQ. PQ is for big battery. PX shorter wire for smaller battery. Kalau terbalik macam ni lah terjadi. Kalau tidak terbalik, atas itu untuk big battery. Below one is a small battery for short segment of wire. Okay. So, guna formula apa? Guna formula ni, LXP over LXY equal to voltage XP over voltage XY. Okay. Let me. Whoa, I'm dizzy. I'm dizzy. Ini dia, ya, voltage XP. Oops, what I'm doing? I'm blur sudah, ya. I'm blur already. Okay, so this voltage XY, here is voltage XY, and below here is voltage XP. Okay, voltage XY is 4 volt. They're parallel. Voltage XY parallel to battery, so 4 volt. So I can write over here, voltage XY is for EMF A. Voltage XP ialah parallel to battery EB. So atas itu tulis EB. Faham tak? For voltage XP is for EB. Okay. So continue. So LXP over 100 cm equal to EB. EB ialah berapa? 3 volt. 3 volt. EA is for a long wire, so 4 volt. Okay. So what is length XP? What is length XP, class? Length XP is 75 cm. Okay, multiply. Now, so if kalau 4 volt 100 cm, kalau 3 volt 75 cm lah. Okay kan? So length XP is just 75 cm. Now question B. If 1 ohm resistor is connected in series with cell A, what is the new balance length XP? This time, okay, I copy again. This the same diagram. Okay. Okay, look at here. Now, okay. Okay, now, now he say he put another resistor in series cell A. That means now he got a battery here. Got a battery here, resistor 1 ohm in series with cell A. This is EMF A, and below is EMF B. So how, class? How? If like this, class. If like this, you must realize, class. This the top here actually got current. Below here when balance is no current. Below here is no current at all. But At the top here got current, positive, negative. So here got current. So here got current, class. And you must also realize that this whole wire is actually a resistor wire. So if you look carefully, this the top here, inilah yang atas ni. If we draw it again, it is something like this only. Okay, EA, and then resistor 1 ohm, and then here we have resistor XY. Do you see that, class? Do you see, class? So these two resistors, they are actually in series. Okay, in series, betul tak, class? So actually you can write a formula. EA is actually current multiply R plus RXY. Correct not, class? Correct not? Ya? Understand, betul tak, class? Ya, yang XY ini sebenarnya satu resistor. Sebenarnya dia satu resistor. So this resistor at the top and resistor at the bottom is actually the same. Yeah, it's actually the same. Yeah, apa saya cakap? Resistor this 1 ohm and resistor XY, they are actually in series. This XY is a resistor. I can put as RXY lah. So I can put this EMF formula, E equal to current multiply R plus RXY, because these two resistors, they are in series. So now, class, I want you to see this. Kembangkan this IR plus IRXY. Okay, so you see EA minus IR equal to IRXY. IRXY is actually, kalau kita nak cari voltage XY, kalau nak cari voltage across XY, means voltage XY ialah IRXY lah. So EA minus IR is actually VXY. Okay? And why is this important? Why is this important? Now I'm going to explain. Yeah? Why is this important? Why I need to tell you this? Because I want to find the balance length. You have a resistor over here. I want to find the new balance length. So I also use the ratio LXP over LXY. Okay, XP over XY equal to what? Voltage. I think I need to okay, I need to here there is this is voltage across XY. This voltage across XY ialah voltage inilah, voltage across this RXY. This one lah. Yeah, voltage XY is E minus IR. So so over voltage XY, the top here is XP, voltage XP, voltage XP. Okay, voltage XP. Now I want to find LXP, the new balance length. Over the whole length is 100 cm. Okay. Now voltage XP. Voltage XP is still EMFB. Voltage XP is still EMFB. Yeah, EMFB. But voltage XY now is no longer. Dulu voltage XY ialah EA. Dulu ialah voltage XY ialah EA sahaja sebab tak ada lagi external resistor. Voltage XY terus ialah EA. Faham tak? Ialah EA. Tetapi sekarang ada satu resistor di sini. So voltage XY sekarang dia bukan EA saja, dia bukan EA. Dia adalah voltage XY tadi kita sudah kira. Saya hampir habis sudah kelas, saya hampir habis sudah. Dulu voltage XY ialah apa? Dulu voltage XY ialah EA. Voltage XY ialah EA sebab tak ada resistor. Voltage XY ialah EA. Tapi sekarang dengan ada resistor, so voltage XY ialah EA tolak IR. So kena tulis voltage XY now is EA tolak IR, bukan EA saja. Dulu EA saja, tak ada resistor. Sekarang ada resistor, kena tolak IR lagi. Itulah dia sekarang punya. Sayang kelas, dia begini. So, dan kita boleh teruskan, gantikan nilai. EB tadi ialah 3 volt. 3 volt dengan EA. Oh, EA tolak IR. Oh, ini kena cari current dulu. Cari current dulu, tak apa. So, cari sajalah current. So, current kita tengok yang ini. EA ialah apa? Boleh kalau ada kelas pergi saja, nanti saya upload di YouTube. So EA ialah 4 volt. 4 volt. Okay. So it is 4 volt equal to current. Resistor is 1 ohm. 1 ohm plus ini RXY. RXY is 5 ohm. RXY is 5 ohm. Okay, so I got the current is 4 divided by 6. What is 4 divided by 6? So 4 divided by 6, it is 0.667 ampere. So I got it. Alright, so EA, just now the EA is 4 volt. So 4 volt minus the 0.667 times the R. R is 1 ohm. So 1 ohm. So I got it. So I got the final answer, LXP. Okay. I got the final answer, LXP. 3 divided by 4 minus 0.667. Okay, so I got that and then multiply by 100 cm. So the final answer is 90.01 cm. Yeah, last time is the balance length is 75 cm. Now increased to 90 cm. Yeah, 90 cm because of because you put a resistor here. Okay. And so that's all lah. Yeah. So that's all for now. So we continue in the afternoon, yeah. Okay, class. Yeah. So thank you. Yeah. So hope you understand, and I'll post this video in the YouTube. All right. Okay, bye.